So welcome to the part 2 of row equivalence. So in this video we are going to apply the rules that we have mentioned in row equivalence. So again, just a sort of review, I'm going to write down the rules for row equivalence. So the rules are: number 1, we are allowed to interchange rows. And number 2, we can multiply a row by a constant. And the last one, we can add one row to another. Let's apply these rules in our matrix. So let's say we have this matrix. So let's try applying the first rule, interchange rows. So when we say interchange rows, we can swap rows. Let's say, for example, we want to swap row 1 with row 3. So let's swap row 1 with row 3. So this is row 1. Let's write here R1, and we will swap it with row 3. Okay, so we will add here R1 just to mark it that we are referring to row 1, and the double-headed arrow refers to the swapping, and R3 meaning R1 and R3 will swap together. So now it will turn this matrix, after applying this first rule, it will be like the first row will become the last row on the first matrix. -2, and then 3, and then we have here our 9. Okay, and then we will just copy the middle row, and then the last row will be the row 1 on the first matrix. So we have here 2, -5, 5, and 17. So as you can see here, these two rows were swapped. Okay, so that's how we apply interchange rows. The row 1 took the place of row 3, and row 3 took the place of row 1. So let's have another example. So this time let's try multiply a constant, or multiply a row by a constant. So let's say we have this matrix. We have 10, 0, and 9. We have 16, -18, and 10. And then we have 2, 15, and 17. And then we have 100, 150, and 23. Okay, so let's apply the rule number 2. Let's say we want to multiply our first row with 1/2. So let's write here 1/2 multiplied by row 1. And same with row 2. Let's multiply our row 2 with -1/3 times row 2. Okay, so there you go. So after applying this constant to each element of this array, we'll end up having this new array. So 1/2 times R1, that is 10. So what is the 1/2 of 10? That becomes 5. 1/2 of 16, that this becomes 8. And then 1/2 of 2, this becomes 1. And then 1/2 of 100, this becomes 50. And then for the second row, negative 1/3 times R2, this is 0. So any number multiplied by 0, it will be always 0. And then negative 1/3 times negative 18. So what is the 1/3 of 18? And since both of these numbers are negative, so the result will become positive. So it is 6, because we have 6 times 3, it becomes 18. So we have 6 here. And then 1/3 of 15, and we have a negative here, so this becomes negative 5. And then 1/3 of 150, this becomes negative 50. And then for the last row, we will just copy everything there. There you go. So this is now the new matrix from the result of multiplying the first row with a constant and the second row with another constant. Okay, so let's have another example. So this time, let's add one row to another. So let's say this is the given. We have 1, 3, and 2. We have negative 3, 1, and negative 2. We have 2, negative 1, and 1. And then 0, 7, and 3. So let's work on this matrix by applying the third rule. Add one row to another. So let's pick a number. Let's work on row 2 and row 3. Let's try placing here negative 3 times 1. So we are applying multiply row by a constant. So there you go. So we have a constant here, multiplying it by the values from the row 1. And then we add the row 2. So negative 3 times the row 1. So negative 3 times 1, negative 3 times negative 3, negative 3 times 2, negative 3 times 0. And all those results will be added to row 2. So this is the row 2. Okay. And then let's again work with our last row. Let's try having negative 2 here times row 1 plus row 3. Okay, so there you go. So let's work on this. So what will happen? So we will just copy everything from the top because we did not write anything. We did not apply any row equivalence at the first row of this matrix. So let's just copy everything there. So 1, negative 3, and 2, and then we have 0 here. So there you go. So let's compute for negative 3 times R1. Negative 3 times R1, so that becomes negative 3 plus R2, this becomes 0. Okay. Okay, so maybe you're wondering why we have this answer, because negative 3 times R1, what is R1? R1 is this, no? Row 1, this is the entire row 1. So we write here 1, then plus R2, so this is the row 2. And we are referring to the first element of row 2, plus 3. So of course, negative 3 times 1, this becomes 3. Negative 3 plus 3, unlike sign, this results to 0. That is why we have 0 here. Okay, so let's continue. So this time, negative 3 times R1, we are already on the second column. So let's write here, negative 3 times R1, that is negative 3, plus R2, we have 1. Okay, so negative 3 times negative 3, this becomes positive 9, plus 1. So this becomes 10. So we have to write here 10. Okay. So next, negative 3 times R1, we are already on the third column. Negative 3 times R1, which is 2. So let's write here negative 3 times 2 plus negative 1. Okay. So negative times positive, this is negative 6. Plus negative 1, this becomes minus. So negative 6 minus 1, then this becomes negative 7. Okay, so we have here negative 7. Okay, for the last column, negative 3 again, times 0, plus R2, that is 7. So this is 0, then plus 7, then this is 7. So let's write here 7. And then let's work on the last row. So negative 2, R1, that is 1, plus R3, that is 2, and this is negative 2, plus 2, and this becomes 0. So we have here 0. Okay. Okay, so next, let's work on the second column. So negative 2 times negative 3 plus R3, that is negative 2. So negative times negative, this becomes positive. This becomes positive plus negative 2. So unlike sign, it will become subtraction. So this is positive 4. So let's write here positive 4. Okay. Let's work on the third column. So still negative 2 times R1, and R1 is positive 2 plus R3, row 3, that is positive 1. And then negative times positive, this is negative plus 1, and then this becomes negative 3. So negative 3. Okay, so there you go. Okay, so for the last column, negative 2, R1 is 0, plus R3 is positive 3, and then anything multiplied with 0, that is 0, plus 3, and this is 3. Alright, so this is now the row equivalence from this matrix. Okay, so that's the end of this video, and then see you in the next lectures.